to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi, I'm Peter Varhol. I'm an evangelist for software development, testing, and DevOps with Technology Strategy Research. And for this talk, we're going to be looking at a new type of cloud architecture called serverless systems. And with my collaborator, Gerie Owen, we're going to be talking about just what serverless systems are and serverless applications are, and just how we go about testing those. So once again, this is Peter Varhol along with Gerie Owen, and I look forward to seeing you there. Thank you. Good day. I'm Peter Varhol, and I'm here with my collaborator, Gerie Owen. And we're going to talk to you for the next 40 minutes or so about testing serverless applications. We appreciate your sticking around to the end of the conference, and we hope to teach you something about serverless applications, what they are, and how to test them. So Gerie's going to say a few words about herself first.
So great to be here. Looking forward to this virtual conference and speaking with you all. I'm Gerie Owen. I'm a QA evangelist, test manager. I'm working right now as a QA architect for Medulin. I do a lot of writing for TechTarget and TechBeacon on testing. And I also present at conferences. And I enjoy running and cats.
And as you can tell, I also enjoy running and cats here. A little bit about me. That's Peter, international speaker and writer. I have graduate degrees in math, computer science, and oddly enough, psychology. At this stage of my career, I really consider myself a technology communicator. I love digging into new technologies and explaining them to other people. As former university professor and technology journalist, cat owner and distance runner, and you can reach me at peter@petervarhol.com. So what are we going to talk about for the next 40 minutes or so? First of all, we're going to talk about, well, what the heck is serverless anyway? What do we mean by serverless computing? Serverless computing and serverless applications. Why, when you're talking about serverless, you also are talking about DevOps. What do we test? We test a number of things, but we also, in our testing process, we both shift left and shift right. And then we sum up with testing strategies for a new architecture, and we'll go ahead and close that out and open it for questions. So anytime you have any questions, you're welcome to type them in. We're going to save them till the end, but anytime you have any questions about what we're talking about, please feel free to ask. So what the heck is serverless to begin with? Well, certainly we're using servers. This does not preclude using compute servers. What serverless is, it's a cloud computing execution model. You supply the code, and it's all application code. You don't have to supply the operating system or libraries or anything like that. Generally, it refers to back-end processing. What we're doing is we're prompted by an event coming from some front-end code. That front-end code is not considered serverless. However, what we're doing is we're accepting inputs from either users or devices or whatever it might be at the front end. And then our code, backend code that does the processing, actually recognizes that we are sending a code, and it processes that code. It's often event-driven. You may or may not be familiar with this term, but event-driven means that we're driven by external events. In this case, we're driven by events that happen by the user, that are input by the user, by devices, whatever it might be. It's not a full application. Your serverless application is not really a full application, but oftentimes it's an API. It does some processing, and oftentimes it can be an interface into still more code.
So one of the most important testing skills then for testing this is going to be your API testing. So you'll need to be able to use Postman and tools of that nature.
And Gerie's absolutely right. So let's talk about what that means. As I mentioned, that the term serverless is really a misnomer. We actually do use servers. We don't, however, provision them and manage infrastructure. We don't go ahead and create a VM. We don't install operating systems. We don't manage updates or anything like that. In fact, serverless, rather than serverless, other names are really more appropriate. We can say function as a service, but my favorite is event-driven computing. So we don't start processing until we have an event that kicks off one or more of our functions. So we also talk about runtime. What do we mean by having an application runtime? You're almost certainly familiar with things like the Java Virtual Machine and the .NET Common Language Runtime. Their runtimes, they're a bit more comprehensive than what we're doing here, but the concept's the same. What serverless runtimes simply do is that they will accept data as input, and they will kick off their code based on that data as input. So most serverless vendors offer their own compute runtimes. I've got a few listed here. What they do is they'll go ahead, as they said, go ahead and recognize that they're getting data as an input and execute their logic. But they, interestingly enough, and we'll talk about this a little bit more too, is that they don't store any data. They're stateless, in other words. So some examples of runtimes, probably the most common, and you may have used this in the past. If you're an extensive Amazon AWS user, Amazon Lambda, there's an open source one called IBM OpenWhisk that can run on multiple platforms. Or for Microsoft Azure, there's Azure Functions. And once again, we're only executing when a particular event occurs. If something comes in, we will go ahead and execute that.
So what's interesting about the fact that it's stateless, that can make your testing harder and easier. Often you want the data back in its original state, but then sometimes you don't if you're executing long business workflows. So we'll talk a little bit more about that later in the presentation.
So once again, each of these runtimes, each of these serverless runtimes, support different languages. Amazon Web Services Lambda supports, well, you can read it there, Java, Go, PowerShell, Node.js, C#, and it provides the runtime API. So if you want to call things that aren't written in that language, you can call those from your individual Lambda functions. Once again, as an example, Azure Functions supports C#, JavaScript, F#, and Java. Also, you can run, although technically it's not supported, Bash, PowerShell, Python, and PHP. So we're going to focus for the next half hour or so. We're going to focus, I'll say more specifically on AWS Lambda, because it's the most commonly used serverless runtime. If you're using another runtime, the activities will be very similar, and what you do and what you see will be very similar, but we've chosen a particular example, particular architecture that allows you to look at it. So once again, the AWS Lambda architecture will take user requests, and as I said, it can be a human user or it can be a device user. This is actually quite good for, I'll mention this a little bit later, but it's actually quite good for the processing Internet of Things applications also. So you end up with an API gateway, and then from that gateway decides what Lambda function is needed in order to execute your particular, that particular input. It may be something as simple as log on, or it may be, as I say here, list products, complete purchase. So they tend to be, the Lambda functions tend to be simpler things. And we break them up into a more comprehensive workflow. We can store from here, although the functions themselves are stateless, so they don't store any data. If there's any data that we once stored from any of the Lambda functions, we've got to go to a separate database such as DynamoDB or an S3 bucket. So why, when we're talking about serverless, why are we also talking about DevOps processes? First of all, serverless is cloud only. On-prem clouds may be possible depending on the runtime you're using, but it oftentimes doesn't make technical sense. You really want to get your data and your processing up into the cloud if it's not there already. Serverless also means containerization. What we're doing is we're processing one step at a time, and we're going through one workflow step at a time also. We can encapsulate these into microservices or even Docker containers if we want to, if we want to go ahead and do that. We can make microservices out of them, as I already mentioned. So we have to decide what size of function that we want to create here.
And of course, so DevOps also means continuous testing and quality engineering versus quality assurance, engineering quality in.
Right. So what's different here in terms of executing the application? First of all, and this is what Amazon, this is what people oftentimes point to as the greatest benefit. I tend to disagree, but you only pay when your code is executing. When you kick off a Lambda function, that's when you start paying into Amazon. It's a good economic model for some types of applications, but I like to think that serverless means so much more than that. Once again, it's rarely a complete application. We're dealing with the backend only, no user interface. The database isn't part of that serverless architecture, although we can use a database. And as we mentioned a few minutes ago, serverless applications and serverless functions, I should say, are stateless. There's no state to reset between tests. Test data is confined to individual sample applications, and workflow means all data is stored elsewhere. We'll talk about the implications of that in just a minute here.
So if you need data in a particular state, that means you're going to have to store it and work from there with it.
So let's talk a little bit more about state here. In fact, developers have demanded state options for serverless. They like the idea of serverless. They like the idea of that you only pay for when your serverless function is executing. So they like that, but they don't like the idea that it's difficult or it's ad hoc to be able to store data. So Microsoft offers a feature called durable functions. So what they do is in the background, they will they'll create storage queues and tables that your data is in. So you can persist between different functions, maybe log on, search items, purchase items, things like that. At each step, you're going to want to store something. How do we go ahead and store that right now? It's not necessarily built in. So Microsoft is offering you durable function. Amazon has a feature called step functions that enables you to create and log into temp folders. And this has implications, any sort of state storage here, any sort of persistence has implications to security, which we'll address later.
So this actually kind of leads a lot into test-driven development and the working on the automation pyramid, because this is where you really need to get a lot of your testing, especially your automated testing, into your unit test level.
We'll see that, as Gerie mentioned a few minutes ago, that the lack of persistence, the lack of state can be good in that it enables you to more easily test individual functions and not have to reset them, reset the data in them at every run through. But it means that it's hard to test either partial or full workflows. So that's something where you need to bring in state and you need to be able to persist your data across, in this case, Lambda functions. So why do teams want to maintain state? Here we are again. For performance reasons, if we're not constantly writing into and reading out of a database, we're improving our performance. Convenience. It's you have to write additional code to get into to write things to a database and to get things out. Also, machine learning. So what we're trying to do with machine learning is we're trying to look at what's happened in the recent past in order to predict what's going to happen in the future. That's machine learning, and having that data more readily available than in a database will really help us in terms of doing that prediction of the future. So Gerie mentioned this also, but how does that impact testing? All of your data may not be returned. It may just disappear when the function is completed. It also makes it difficult to tell if the function is operating correctly because you can't look at outputs. This makes testing a bigger challenge.
Yeah, especially when you get to your end-to-end testing, you need to have your data persisting, so you're going to have to store the data in order to do your end-to-end systems test.
So as I mentioned also, runtimes, serverless runtime can also execute edge computing processes, such as Internet of Things. This is actually a really effective way of being able to collect data from devices, whether they be measuring equipment or sensors or whatever it might be. Lambda functions and other serverless functions can execute small amounts of code on the devices and also bring code in and do real-time processing on that code. So if you're collecting data from sensors, for example, and you need to know something right away, serverless computing is a great way of doing that. So it's also good for distributed data systems. If we've got something that data is coming in from a wide variety of different places, serverless computing can help us collect and process that data within the context of our serverless application. So how about testing strategies? We're going to talk a little bit about testing strategies here. First of all, in terms of what we need to understand and what we need to do while we're testing, we need to understand the relationship between the code and the runtime. We need to understand that the code is really separate from the runtime. All the runtime does is kick off the code. We need to shift left farther into earlier in the development process to be able to test.
And of course, that's a positive thing.
Yes, it is.
Because the earlier you test, the quicker you find defects, the less expensive and the easier they are to fix.
And API testing, once again, Gerie mentioned that earlier. We're very interested in what goes on when we're passing data between functions, especially if some of those functions actually leave the serverless application and execute independently. We have integration testing. Because what we're doing when we have serverless, and the first time Gerie and I gave this presentation, we actually were, after the presentation, we were talking to some 2 or 3 people who came up afterwards. One of them said, we asked, are any of you doing serverless computing right now? Or any of you have any serverless applications? And one fellow spoke up and said, we've got 500 Lambda functions in AWS that are spread across about 3 or 4 different applications right now. So once again, one of the benefits here, if I can go back and talk about benefits again, one of the benefits of using serverless computing is you've got those functions. So if you've got, for example, log into a site or log into an application, that Lambda function can be shared across multiple applications. But we're trying to integrate these applications into a whole. So integration testing for each individual application is very, very important. Then we have performance and load testing, which we're very concerned about with regards to anything that has to do with workflow. Security testing, and we'll address that. It's kind of an interesting change with security, but yes, in the cloud, we do have to be concerned about security with serverless applications. And then we can get into, as Gerie's already mentioned, continuous testing from there.
And you need also to consider your microservices, because often you're going to have those, and you need to plan for testing not only the data being transferred, but also the contract between the provider and the receiver.
So the relationship between the code and the runtime. So while the cloud vendor will provision the services, it will be what the operating system really doesn't matter. It can be Windows, it can be Linux, it can be more plain vanilla Unix. It can be whatever operating system the cloud provider happens to be using, as long as its runtime will run on that. The OS really doesn't matter. The cloud vendor does provide security up to the runtime, but we'll mention that even though this is standard in terms of what cloud providers do in the way of security, there's a twist with serverless applications that you need to be aware of. And all the runtime does is it kicks off the code. It does nothing else. It just starts the execution and informs the API gateway when it's done to go to the next part of the workflow. So what does this mean to testing? First of all, only the code needs to be tested. There's no interactions with the runtime. There's no interactions with the operating system, no calls into either the runtime or the operating system. You really just need to do unit testing on your code. Now, it's a bit, I'll say, a bit more complicated than that.
Yeah.
It's a bit more complicated than that, but I can say with honesty that it's a lot of it has to do with testing those individual functions. Now we're combining those functions into workflows and have to be concerned about performance and security, which we have to test for.
And functions too. You have to be concerned about the components, that the components work with each other, and of course that's a little bit more complicated in this model.
And as we mentioned, persistence. So you have to be concerned with any data that's being written into or read from a database or written back to the user interface.
So shifting left, this is a very important part of serverless testing. It starts with really working together with the developers. You need to plan the test at the same time that you're coding. You need to actually be writing the test and coding to the test to make it pass. And that involves understanding the application architecture so that you can make suggestions on the testability. Unit testing is critical because this is where you're really going to get the function of the functions tested. And then the next part, you need to actually map out the integration points so that you're certain that you're testing that the components all work together.
Yeah, and just as important as the components working together, they've got to be, I'll say, they've got to logically work together too. You have to write the or pass steps on the workflow from one function to another. So you need to find out how they integrate together.
So with integration testing, all of the functions are intended to execute under serverless, and that means that you need to be able to ensure that they're all working together, and that means to start with getting the unit testing done, because it's kind of hard to tell if you don't know for sure that they're all working individually, then you're not going to be able to track back to the bugs. All of the services also need to be tested. The services that are used by the serverless functions, like the database, the web services, the microservices, potentially micro apps. API testing, again, is very critical here to make sure that your data is being sent and received accurately in the same format. And finally, you need to do that full systems test with the simulated workflows. You need that end to end, which, if you've done all the back testing, if you've done the testing on the back end, then your full system test should go easier.
And Gerie's right. Many of the individual functions that you'll write, individual Lambda functions, are relatively simple. They may well be tested primarily or entirely with unit tests. It's how these, how the workflow, how these functions work together, how the workflow flows, and how the workflow may flow depending on what data and results you get make testing here a real challenge. So with regards to API testing, we've already talked about API testing, but testing the APIs within any serverless functions, any Lambda functions, we've got to do also. If we're calling out to other code, if we're calling out to other applications, we need to make sure that they're tested appropriately. Once again, for the correct results, are we passing data in and out of a particularly legal range of data? Is the response correct? And am I getting it in the right format?
Yeah, that's a critical one, because if the format isn't right, there are definitely going to be errors. And then, of course, the performance and load, if it's slow, then you definitely have a problem.
So yeah, we'll address performance and load more specifically in a minute here, but you can test, the good news is that you can test many serverless functions by invoking the runtime locally. Yeah, AWS Lambda and IBM OpenWhisk let you actually run local rather than to have to take the time and effort and prepare the proper formats to go into the cloud. So we can go ahead and invoke the runtime, in this case, AWS Lambda locally. We can run the function in a wrapper within the runtime, and we can use tools such as the AWS simulated application module locally. So we can also test them within Docker containers, so they can be tested within containers locally too. So once again, for unit testing or for more comprehensive testing of individual Lambda functions, it probably makes sense to do a lot of that locally at first. But eventually, you're going to want to upload it into the cloud, upload it into your production environment, upload the function, prepare sample events, go ahead and invoke the runtime. And there's a nice little, I'll say, graphical development kit or graphical development UI that enables you to do a lot of this without uploading, invoking the runtime, invoking your function without having to actually execute the entire application. And then you want to observe the outputs to make sure it's what you expect.
So continuous testing and serverless, they absolutely go together. And sometimes you talk about continuous testing, sometimes people equate it with test automation, but it means different things to different people. But what it really is, it's an approach to managing risk by not only improving the test efficiency, but increasing the effectiveness of the test processes. And assessing and mitigating business risk is the primary goal. So that means that you need to focus on quality at every stage during the process. You have to take more of a quality engineer quality in, start from the beginning with the unit testing, and that's really critical in serverless and continuous testing. So that's why it's incredibly important. I know some people equate continuous testing with test automation, and test automation, of course, is the backbone of continuous testing. You certainly can't do continuous testing without automation, but it's more than writing your scripts, running them, waiting for the results. It really is running scripts and integrating code, testing not only the code, but also the builds through the process, and getting quick feedback, getting that feedback immediately so you can make quick corrections.
And immediately is just so important. I was on a development team about a decade or so ago where we felt really good about ourselves because we were doing nightly builds. And we would run smoke tests right after the nightly build. So the next morning, we'd come in and be able to see what if the build worked, any errors from the smoke tests, and things like that. However, continuous testing is a lot more compressed. We're not doing nightly builds, we're not doing weekly builds, we're not doing monthly builds. We are building every time we have a check-in. So that means that we need to check in and be able to kick off at least some tests as a part of that check-in process. That's all a part of our developer and tester workflow.
And the goal is no human intervention within the pipeline. So just some things about automated tests, since they are, the most important part of continuous testing, the most important technique, we'll say. It's really important to run the automated tests in parallel. You need a certain amount of tests to get a good test coverage, but you can't let a test suite run for hours. It just doesn't work. So if you run the test suite parallel on multiple virtual machines, then you will speed up by the number of machines that you have. And it's important to follow the best practices that you would for any test automation, including atomic tests. You want one test per test script. The test shouldn't rely on the results of the previous test, because that would cause a bottleneck if one of your tests fails. You want to keep them quick running, maybe just like a minute on the local environment. And finally, the importance of managing the data. The data should be put back to its original state, or stay in the state that you need for the next test. So why does serverless need continuous testing? Well, as we've seen, the orchestration between the components can be very complex. How are they calling each other? Are they calling each other properly? Is the performance acceptable? And the interaction between the components and the external services can change. They can be in different locations. It can be expanded calls, and of course, continuous testing is always really cloud-based.
So let's talk a little bit about performance and load. We mentioned that earlier. Each function requires separate performance testing. We need to know the average time to execute, and also the ability to execute under an increasing load. As our load, especially if we're doing things where we're expecting a lot of inputs, a lot of invocations of these Lambda functions, we need to understand that as we increase that load, as we increasingly call those functions, that they're still, I'll say, simple enough and streamlined enough to be able to go ahead and execute without performance degradation. And then not only with individual functions, which we can do locally, as we mentioned, but also entire system performance testing. We need to integrate entire workflows, and we need to take those workflows and create sample workflows from them, and be able to understand our performance and understand our performance under load with each and every conceivable workflow that might come out of the application. The cloud vendors offer individual performance and load tools for local testing, or in the cloud for if you're able to do so. You can use JMeter or a commercial product. Now, most commercial products, and I know for a fact JMeter, but also most commercial load testing products will allow you to test workflows while they are executing in the cloud. Security. Security is an interesting aspect of serverless applications. Each function where I said that I had somebody at a presentation says we've got 500 Lambda functions. Well, that's a different way of looking at that from the standpoint, for example, of your DevSecOps people. That means you have 500 separate entry points into the application, and all of those functions, all of those entry points have to be tested for security. Now, the cloud vendor provides security through the runtime, but if you're doing things like allowing code to come in from places other than the API gateway, if you're calling out to databases, if you're calling out to other external applications, then this becomes problematic. Your application will likely consist of multiple components, which means that probably one of the most, I'll say, complex and difficult things that you're going to be doing, complex and challenging, I'll use the word, will be testing your application for security.
So as much as it's important to shift left, it's also important to shift right. Performance monitoring and testing in production, and I know testers just cringe at the idea of testing in production, but you need to find any issues, especially with continuous testing. You're moving so fast, there are bound to be issues that show up in production. So the point is to catch them before your customers do.
If you're not already monitoring in production, you should be. And by monitoring, I mean really just make sure the application is doing what it's supposed to be doing. It's performing well, it's available, and as load increases, it is able to handle that load. What we also do when we shift right is we create synthetic tests, things that I'll say that may be recorded as actual things that users would do, or things that you think users will do with the application. We call those functional tests pre-production. We call those synthetic tests post-production when we're in when we're actually in production. Also, health analytics. We want trends over time. We want to know, is our application still healthy? Yeah. Is performance trending well? Are we creating? Are we executing things and not getting any more errors than we did an hour, 2 hours, or a day ago?
So testing is easier in some ways. There's no testing on different configurations or browsers. It's all browser agnostic. Of course, the serverless functions themselves are relatively simple. And the APIs and the workflow are the most important tests. But it's also harder because it depends on the architecture. Programmers aren't necessarily familiar with the event-driven systems. I think testers now are becoming a lot more familiar with them, but it makes the interactions between the components a lot more difficult to test.
And from those of you who are old timers in writing interior applications, I say this is really MVC. This is model view controller, but it's on steroids because we've got multiple models, we've got multiple views. We do have a central controller, but this really is that same old 10-year-old architecture, but it's really on steroids because we're executing more complex workflows. So serverless, to sum up, serverless brings an interesting new wrinkle to cloud computing. Testing needs to adapt to the realities of serverless because this application architecture is just going to be used more and more over time. It's got to occur, testing's got to occur throughout the life cycle. It's got to include monitoring, health analytics, and testing, synthetic testing in production. But one of the advantages is that we're really just testing the code. We're not testing its interaction with either the runtime or the operating system. So our skills still apply. Yeah. We're not doing anything substantially different than we do as testers for ordinary cloud-based applications, but there are some interesting differences. And if you have any questions, please go ahead and type them in. I don't know that we have. I don't see it. Can you refresh that maybe? Or reload the page? Or
You want me to reload it?
Yeah, go ahead and
I should do
reload.
that. It's this one. Where did my mouse go? Oh, here it is.
Friends, and hopefully learn something this last session. Thank you very much.
Thank you.